Hello, welcome back with me, your friend, Edu Ada. Now, we quickly talk about another aspect of trigonometry, that is special angles. Special angles. Now, we have special angles, and those special angles, okay, let's quickly talk about them. The special angles are between the range you have 0, 30 degrees, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. There we go. So let's consider 45 first. How do we calculate or solve, get the special angle for 45 degrees? The trig ratio of the special angle 45 degrees. Let me use, this is not, I'm going to use a square. A square, yeah. This is a square. So that if we have this, let me wipe this. But I'm wiping everything. So if you have this, you have a square. So having a square, let's say this is a square. Yes, this side will be drawn again. So if this is a square, I'm going to draw my square this way. Then we can, we all know if this is a square, we know this is 90. Is a right angle, is a right angle, is a right angle. Now let's assume I'm drawing a diagonal that bisects it into two. So I have something like this. Let me say let me go from here. Yes. So that implies this will be 45. This will definitely to be 45 degrees. Do you get that? So let me name the angles. Let me name it A, B, C. So I need a triangle that has been formed out of this. I need this triangle alone. So don't forget, if this is a square, I can take all the sides to be 1, 1, 1, 1. They are the same thing, right? Good. So if they are the same thing, I can now quickly solve for the trig. I can get out the trig of those, the identity of this angle. So I can say now I know my sine theta, or sine, I'm using 45 now as the angle now. Using sine 45. Let me not confuse you. Let me wipe this. This is only 145. So we have sine 45. But before we find sine 45, we have our opposite one. We don't have our hypotenuse, isn't it? So there we go look for hypotenuse. So our hypotenuse square, which is supposed to be the opposite square, to be equal to 1 squared plus 1 squared. So hypotenuse should be equal to 2. 1 plus 1, that is 2. So hypotenuse will be equal to the square root of 2. So which implies that what we should have here will be square root of 2. Do you get that? So which means we can now look for our trig functions of those angles. So sine 45, which is opposite. This is opposite of our hypotenuse. That will be 1 over root 2 cos 45 adjacent. This is opposite. This is adjacent. Adjacent over hypotenuse. Opposite over hypotenuse. Adjacent over hypotenuse. We have 1 upon root 2. Then we have tan 45, opposite over adjacent, that is 1 over 1, and that is just 1. Do you get that? Or you just use it sine 45 over cos 45, you will still get the same answer. 1. Root 2 and root 2 will cancel out. So that is tan 45. Let's find for 30 and 60. If we look for the special angles of 30 and 60, what we use will not be a triangle. What we're going to be making use of will be an equilateral triangle. An equilateral what? Triangle. An equilateral triangle. So if you are making use of an equilateral triangle now, let me draw one. Then, since it's an equilateral triangle, let's see what we have. So I want to bisect this. So bisecting that, an equilateral triangle such that I will make all the sides to be equal. Then I have 2. This is 2. This is 2. So this will be 1 and 1. Do you understand? Because I've bisected this into 2 equal halves. So 1, 1. Then I have, since an equilateral triangle, of course you should know, this is 60. Because equilateral, all the angles are equal. So 60. This place has been bisected into 2. So the whole, this will be 30. Yes, we need only that side. Let me name this A, B, C. We need this. So this is what we need. We have this place to be 2. We have this place to be 1. We have this place to be 60. We have this place to be 30. So we need the height. Don't forget, the height is the opposite here. 2 is the hypotenuse. 1 is the adjacent. So 2 square, using Pythagoras theorem, 2 square should be equal to 8 square plus 1 square. Do you get that? So that will be 4 will be equal to 8 squared plus 1. So 8 squared can be equal to what? 4 minus 1. So h itself can be root. 4 minus 1 is 3. Then you take square root of both sides. That will be root 3. So definitely our h here will be root 3. So here we'll now be having root 3 here. You get that? Now if you are to now look for sine, say you want to calculate sine sine 30, but let me remove these two and put root 3 there. Sine 30 means opposite upon hypotenuse. Punch your calculator, you will get 1 over root 2. 1 over 2 rather, which is something as 0.5. Then cos, instead of 30 I wrote theta. So this is 30. Cos 30. Adjacent. This is 30. This is the opposite of 30. The adjacent of 30 is this. Adjacent over hypotenuse. So that is root 3 upon 2. Tan 30. Tan 30. Opposite over adjacent. 30. This is tan, which is 12. Opposite over adjacent. So that is 1 upon root 3. Then let's look for the 60 series. Sine 60. That should be equal to what? Sine 60 opposite over hypotenuse. That is root 3 over 2. Cos 60. Cos adjacent. This is opposite of 60. Is adjacent of 60. cos 60. Adjacent, so this is the hypotenuse. The hypotenuse does not change for both of them. They share the same hypotenuse. So adjacent, which is 1, for 60, this is the opposite, this is the adjacent. 1 is the adjacent. Adjacent to hypotenuse. So you have 1 over 2. Then we have tan 60. Tan 60 is what? 2. Opposite to adjacent, root 3 over 1, which is the same thing as root 3. Do you get that? Now let's quickly consider for 90. 90 is a special angle too, but you should know this. Note this. Before that, note this again. That you have relationship. Okay, probably I'll take that later. The identity for these angles. We observe that our sine 30 is equal to our what? Sine 30 was equal to cos 60. Do you get that? So that is a trig identity you should identify there. That means the sine 30, let me say sine 60, and be equal to what? Sine of opposite, we have 90 minus 30. Do you get that? Now let's quickly talk about the 90. For 90, we have them to be, for that is 0 and 90 rather. Let's talk about 0 and 90. 0 and 90. 0 and 90. So we have for 0 and 90 your sine 0. Okay, let me just write this here. 0 and 90. So sine 0. 0 and 90, their identity is between 0 and 1. So just have not, you don't have to cram them. It's simple. Sine 0 is 0. Sine 90 is 1. I can draw the graph without you will easily identify that. So that will be in another video. Using our graph to get our special angles. Yes, especially for angles between 0 and 90. Yes, even beyond 90, 180, 270, 360, and on and on. So sine 90 is 0. Let's use cos. Cos 0, it is 1. Y cos 90 is 0. Then tan 90. Tan 90 means sine 90 over cos 90. Oh, okay. Yes. Tan, let me first write 0. So tan 0. Tan 0 means sine 0 over cos 0. And that will be 0 over 1, and that is 0. So tan 90. Tan 90 means sine 90 over cos 90. And that is 1 over 0. 1 upon 0 is undefined. Undefined. You get that? If you punch tan 90 in your calculator, you see it will give you undefined. Thank you very much. Please subscribe. Thank you. Thank you. I need your comments too. Bye.